Hello friends, this is your chemistry teacher, Dr. Shaukatali. Glad to meet you in this wonderful online Google Classroom. As usual, I'm going to teach you the organic science. The topic now I have selected to discuss in this particular class is heterocyclic compounds. In particular, the compound is furan. C4H4 and O is the molecular formula of furan, and its structure is this. Yes, this is your basic structure of your furan. This is a 5-membered heterocyclic aromatic compound. This comes under aromatic category. This is your aromatic compound. When it behaves as aromatic compound, when it exhibits aromaticity, the property, a specific unique property of aromatic compound, the lone pair of electrons of oxygen, what we have over this oxygen of furan, is involved. It goes into the ring circulation. As a result, this goes here and this comes here. And likewise, there is a delocalization of pi electron is possible in furan. That makes the furan an aromatic compound. This delocalization of pi electron in turn gives you the stability to this furan. So furan, it is very clear that the furan is an aromatic heterocyclic 5-membered ring compound. Its molecular formula is C4H4O, carbon 4 number, hydrogen 4 number, and just one oxygen atom. This is your heteroatom in this aromatic compound. And this particular furan is highly volatile, exists in liquid form, highly volatile compound, flammable compound. Its boiling point is almost equal to the room temperature, around 32 degrees Celsius. As a result of this, it goes to the vapor state very easily. It's highly volatile, liquid in nature, flammable easily. Boiling point is around 32 degrees Celsius. This is aromatic compound. Now in this class, as far as the syllabus is concerned, with respect to furan, we are going to discuss the preparation, properties and applications of this furan. Only these three things, under these different topics, we are going to discuss the furan. Anyway, the furan preparation, properties and application is very simple. We will try to discuss the entire thing in this classroom itself. The next thing is your aromatics. I told you that furan is an aromatic compound. How to confirm that this is an aromatic compound? There are two things we have: theoretical confirmation and another thing is laboratory confirmation. You know very well that whenever the suspected compound is given in the laboratory to you, and when you are asked to confirm whether the given compound is aromatic or aliphatic, what you people do? Simply, you used to take the given suspected compound in a spatula and heat it and introduce this given compound. Have it over the spatula and introduce it to the edge of your Bunsen flame. It will catch fire immediately and burns with a sooty flame. Once the sooty flame comes out, that ultimately confirms your presence of an aromatic compound. Thereby you can easily confirm that the given compound is aromatic. Theoretically, how to confirm this given compound is aromatic or aliphatic? Simple thing. Aromatic compounds obey a special rule called Huckel's rule. Huckel's rule we use to confirm the given compound is aromatic or not. This rule, the basic rule of this Hercules 4, otherwise called as 4n plus 2 rule, where n is an integer that starts with 1, 2, 3, etc. Depends on how many rings we have. In Furan, the ring is just 1. When you apply this one, 4 into 1 plus 2 gives you the 6, similar to your benzene. Exactly, it resembles benzene in chemical property. This furan also undergoes substitution reactions like your benzene. And the result what we get is that is 6. Same thing what we get in the case of benzene also. Whenever we get 6 after applying into the Hercules rule, this confirms that the given compound is aromatic. 6 pi electrons should be there in the furan. 2 here, 2 here and 2 here. 2 plus 2 plus 2. Totally we have 6 electrons in furan also. Since we have 6 electrons as per your Hercules rule confirms that this particular furan is an aromatic compound. Furan can also be drawn like this. We can also draw the furan like this, or the furan can also be drawn like this. Both are same. Anyway, this is 5-membered aromatic heterocyclic compound. Now we are going to discuss the preparation of this furan in the laboratory. Preparation of furan in the laboratory. This is prepared in the laboratory starting from your furfural. This is your furfural. This is your furfural. The furfural undergo an oxidation using zinc oxide and chromium trioxide, powerful oxidizing agent, gives you the furan finally. Gives you the final product. Here is your furan. And this furfural in the laboratory is prepared by using, just have a look what I am writing, then I will explain how to prepare this furfural. CHOH thrice CH2OH. This in turn is prepared from H2OH plus, that is hydrolysis of pentosan, C5H8 and O4 n times. This is your pentosan. Pentosan, a 5-membered 5-carbon atom containing poly, you know that 5 carbon containing your polysaccharide. The polysaccharide unit contains a 5-carbon atom is your pentosan. The pentosan in the first step undergo hydrolysis, acid hydrolysis, gives you aldopentose. This is your aldopentose. Pentose is because of 5 carbon atom. 1 here, 3 here, 3 plus 1, 4 and 5. 5 carbon atom containing compound aldehyde is pentose. Aldopentose. Since we have aldehyde group, therefore this is aldo based on the 5 carbon atom. This is pentose. Therefore this is aldopentose we get when we treat the pentosan, that is polysaccharide. on acid hydrolysis gives you the aldopentose. The aldopentose further on treatment with your sulfuric acid, 3 molecules of water is eliminated, gives you the furfural. The furfural then undergo oxidation using a mixture of zinc oxide and chromium trioxide, gives you the furan. So this is simple process of making your furan in the laboratory. 5-membered aromatic heterocyclic compound. I repeat, preparation is very simple. The preparation starts with the furfural. Anyway, furfural is not available readily. Therefore, this is prepared in the laboratory easily from your pentosan. Pentosan on acid hydrolysis gives you aldopentose in the first step. Aldopentose further undergo hydrolysis using your sulfuric acid. That is, when treated this with sulfuric acid gives you the furfural. Furfural then undergo oxidation, gives you the final product, our furan. As I told you, this is a colorless liquid, easily volatile, flammable, and its boiling point is very close to your room temperature, 32 degrees Celsius around. Now we are going to discuss the properties of furan. With respect to property of this furan is concerned, property reflects properties of this furan resembles exactly your benzene. We know that benzene undergoes substitution reaction very easily. Furan also undergoes substitution reaction. And with respect to the position of substitution is concerned, the substitution in furan takes place only at position number 2, similar to your pyrrole. Second position is the favorable position. This is the only position the substitution used to take place. And in properties of furan, let me write all the possible reactions of furan, chemical reactions of furan, that is substitution reactions of furan. Just wait. I am drawing the furan in between, that is in the middle. Furan treated with bromine. Furan that is when treated with bromine using dioxane at 0 degrees Celsius gives you 2-bromofuran. This is your position number 2, and this also position number 2. If you count from anti-clockwise, this is position 1 and this gets position number 2. And if you are counting from clockwise, this is again position 1 and position 2. Both are position 2. Therefore, at position number 2, bromine gets substituted. The substitution of proton of your furan at position 2 is now taking place by your bromine. Therefore, the product is 2-bromofuran in a reaction called as bromination of furan, or simply bromination. That is, since we use the bromine, this is your bromination. In general, bromine comes under halogen. When we use halogen, usually the substitution takes place like chlorine, bromine. When we get chlorobromine, 2-chlorobromine, 2-bromobromine, etc. Therefore, in general, since we are using the halogen, this reaction comes under, this reaction is called as halogenation of furan. Next, the second reaction is, treat this furan with concentrated nitric acid in presence of your HOAC, that is acetic anhydride, at 10 degrees Celsius. You will get SO3H. This is your 2-furan 2-sulfonic acid. Furan, since at position 2 there is sulfonic group, there is SO3H group, therefore this is your 2-furan sulfonic acid in a reaction called sulfonation. This conversion is called as sulfonation. And this is your halogenation. So halogenation is over, sulfonation is over. Similarly, I'm sorry. This is your nitro. Since we are using nitric acid, NO2 is the ultimate electrophile. This is the one that's substituted here. Therefore, the final reaction is your called nitration of furan. Nitration of furan. Then the third step, use sulfur trioxide. Sulfur trioxide, pyridine at around 100 degrees Celsius. The furan will be converted into SO3H. Furan 2-sulfonic acid is the product. Furan 2-sulfonic acid is the product. And this particular conversion is called as sulfonation of furan. Sulfonation of furan. This is sulfonation. Similarly, we have one more reaction, that is when furan is treated with your acetic anhydride, HOAC. Acetic anhydride, you will get COCH3, acyl substituted furan in a reaction called acylation of furan. This particular thing is called Friedel-Crafts acylation. When we use the furan when treated with acetic anhydride in presence of boron trifluoride as a catalyst, the product what we get is 2-acetyl furan, the final product in a reaction. This particular conversion of furan into 2-acetyl furan is called Friedel-Crafts acylation. Friedel-Crafts acylation. Just wait, I'll write down the name of this. This is a very important one. Friedel-Crafts acylation. Friedel-Crafts acylation. So we have number of reactions, possible chemical reactions. As far as the chemical property of furan is concerned, furan reacts with the bromine using dioxane at 0 degrees Celsius. Furan will be converted into 2-bromofuran in a reaction called halogenation. Furan, on the other hand, when treated with concentrated nitric acid using acetic anhydride at 10 degrees Celsius, the product what we get is 2-nitrofuran in a process called, in a reaction called as nitration of furan. And on the other hand, when furan is treated with sulfur trioxide in presence of pyridine at around 100 degrees Celsius, the product what we get is furan 2-sulfonic acid in a reaction called as, that is sulfonation of furan. Furan then on the other hand treated with acetic anhydride in presence of boron trifluoride as a catalyst. The product what we get is 2-acetyl furan in a reaction, special reaction named as Friedel-Crafts acylation. These are the few important reactions usually the furan exhibits. And finally, apart from this, we have one more important reaction that reflects not only the chemical property of furan, also the applicability, the application side of furan also one can understand very easily. This particular reaction is nothing but your reduction reaction of furan. Just listen. We are going to discuss the reduction of furan. Now the furan under reduction, that is in this particular reduction reaction, the furan on catalytic reduction, palladium as catalyst, catalytic reduction. Furan will be converted into tetrahydrofuran, commonly named as THF. A powerful, sorry, it's not palladium, this is nickel. Tetrahydrofuran is your final product. This is your powerful solvent, organic solvent. Tetrahydrofuran, powerful organic solvent. So reduction, as far as reduction is concerned, the furan undergo catalytic reduction using nickel as a catalyst will be converted into THF, that is tetrahydrofuran. So regarding the application of this furan, the main application of furan is furan can be applied in the form of tetrahydrofuran. This we get ultimately when furan undergoes catalytic reduction using nickel as catalyst. The THF we get finally tetrahydrofuran. This is your main advantage of furan. Now with this, since we are almost at the end of the discussion, as I told you, as far as the furan with respect to your syllabus is concerned, we need to discuss what is furan, what are the important points to be remembered with respect to furan, like what is furan, the molecular formula of furan, boiling point of furan, then whether it is liquid, what type, what nature it is. It is a liquid naturally, and it is volatile, it is a flammable, boiling point is almost equal to room temperature. These points to be remembered. Then as far as the the main property like aromaticity is concerned, this is aromatic in nature. How to confirm the aromaticity? I told you that there are two methods available. Theoretically, if you want to confirm the aromaticity, we need to follow your Huckel's rule. Once we apply the Huckel's rule in this furan, the furan exhibits a result that is equal to 6. This is equal to your benzene, therefore this is an aromatic compound. And in the laboratory, simply by burning this furan a little in a spatula, since it burns with a sooty flame, again ultimately confirms the presence of your aromatic compound. And regarding your chemical properties of, that is preparation of the furan is concerned, the furan can easily be prepared starting from furfuran on oxidation using a mixture of zinc oxide and chromium trioxide. The product furan we get. Furfuran can also be prepared easily in the laboratory starting from pentosan that I have explained. Next, the chemical properties of furan. Furan undergo easily the substitution reactions like benzene, and here the substitution is possible only at position number 2. And this I have explained by taking the halogenation of furan, sulfonation of furan, nitration of furan, Friedel-Crafts acylation of furan, and finally we having the help of your reduction in to what extent the furan is applied, how to convert the furan into tetrahydrofuran, a powerful organic solvent. These things we have discussed in this classroom. This is our first classroom, and please be attentive in the classroom as usual. When we were in the normal classroom where we used to have the face-to-face contact, one-to-one contact, where we used to clarify your doubts. Since we are very far and the pandemic, COVID-19 restricted we people to meet in the normal classroom, and having all these things in mind, be attentive in the Google Classroom. Try to understand the concept. If you have any query or any doubt, you can ask your doubts, whatever the doubt may be, via the Google Classroom. I will try to assist, and I will try to rectify your doubts then and there itself. Till then, goodbye. We'll try to meet in the next Google class with with a new topic. Thank you. Till then, bye.